Recording in progress.
Hello everybody and welcome to this prelim to my video and to my seminar for the Panhellenic Logic Symposium. And first of all, I want to thank the organizer for having me here and for giving us the possibility to still share our seminar and our talk. Even though we don't have the possibility to come in presence in Volos. And I'm looking forward to see you all next year. And today I will talk about a new result in the foundations of mathematics, and that is the comparison between the ZFC, the classical set theory, and the V-logic multiverse. That's a novel set theoretic multiverse conception that I, together with Claudio Ternullo, developed in the last years, and I will compare them using the mathematical methodological principle maximize from MEDE. And as you will see, I argue and I contend that ZFC is restrictive compared to the V-logic multiverse, or another way around, the V-logic multiverse maximizes over CFC plus large cardinals, obviously. So we can start. I will first of all give you some preliminary remarks, give you some definitions needed. For example, I will define the multiverse, give the axioms, and talk a little bit about maximize. Then I will give you the definitions about the sharp generation, and we will see that this set theoretic method is needed for my argument. Then I will give you a sketch of my argument that ZFC plus large cardinals is restrictive compared to the V-logic multiverse. And then in the concluding remarks, I will sketch the road ahead and the further step I can take to get a better comparison. So we start with the preliminary remarks. So my talk is inside the multiverses debate. And in set theoretic foundations in the philosophy of set theory, in a recent year, this debate raised, and we have universalism that says that there exists only one set theoretic universe, B, the cumulative hierarchy that we all know, and this universe contains all the possible sets and thus cannot be expanded in any way. On the other hand, we have multiversism, and according to which there are several set theoretic universes, each one instantiating a different axiomatization and concept of set, and crucially, they can all be further expanded, for example, using forcing, adding new ordinals, and while in the case of universalism, we say that, for example, when we add a new subset using forcing, we are adding them to accountable transitive models of ZFC inside V without adding to the whole universe, because that is impossible. And me and Ternullo, we developed a new kind of multiverse conception that goes along with Hamkin's multiverse or the Friedman's hyperuniverse or the still set generic multiverse, and this is the V-logic multiverse. And we use the infinitary logic, V-logic as the background logic, and this is an infinitary logic that was first developed by Barwise in the 70s, and it's quite strong and powerful to talk about set theory, and is based upon the language L kappa plus omega that essentially says that it admits infinitary conjunction and disjunction of length less than kappa plus. That's in our case is the first successor of the least inaccessible cardinal. And however, we admit only a finite number of quantifiers in front of the formulas. And Our multiverse is the collection of all the possible outer extensions of the ground universe V, generated through set generic, class generic, upper class forcing, whatever you can think about. And obviously, we also say that we have all the possible inner models, mantle, and you can use set theoretic geology to go all the way down also. And we propose that this multiverse is axiomatizable, and we actually axiomatize it. And the first and most important axiom is the multiverse axiom schema. And this essentially says that for any first order sentence phi with a parameter from the set theoretic universe from the ground B, if the sentence of V-logic that expresses that W is an outer model of V satisfying this sentence phi, this property phi, and if this sentence is consistent in V-logic, then there is a universe W in the multiverse that is actually an outer model of V, and that satisfies phi. And then we also add a core axiom that says that every universe of the multiverse models ZFC plus large cardinals. And these are essentially all the axioms needed for this multiverse. And in particular, the first axiom says that we can actually point out to outer extensions of V, real, proper, and countable outer extension of V, that we cannot do that in classical set theory. And then at this point, I take maximize. And this principle was first introduced by Mandy and in 1998, and says that when deciding which foundational framework we ought to use as our foundations of mathematics, we should prefer the one that proves more isomorphism types. So for example, Mandy used this principle to argue that ZFC plus V equals L is worse than ZFC plus there exists zero sharp, or there exists unmeasurable. And why? Why is that? Because ZFC plus there exists zero sharp proves the existence of non-constructible sets. And in turn, this means that we can prove that ZFC plus there exists zero sharp proves an isomorphism type that cannot be realized by a constructible set, that is in ZFC plus V equals L. Hence, Madi argues that ZFC plus there exists zero sharp maximizes over ZFC plus V equals L. And this is essentially the argument I want to make in this talk. Mutatis mutandis. And to do so, I will need to start talk about sharp generation. And sharp generation is a way in set theory to produce higher and higher models. And first of all, we start with the definition of class iterated sharps. And we say that class iterated sharp is a transitive structure and U such that, first of all, it is a model of ZFC minus, that is ZFC without the power set axiom. And be aware that this is at least a model of ZFC without power set axiom. It can be also a model, and in our case, it is a model of ZFC. And this definition was, and all this talk about sharp generation is from Antos, Button, Friedman, and Honzik that made most of the results here. And moreover, this structure has a critical point K, where K is the largest cardinal and it is strongly inaccessible. And a critical point is the first cardinal that is then embedded not to itself, but a little bit higher. Then we say that the structure is amenable, that is that X intersected with U in N for any X in N. U is a normal measure on K in the structure. And finally, it is iterable in the sense that all successive ultra-power iterations along class well orders are well founded. So we start with one structure, and then even if we keep iterating these sharps, we still we are still in a well-founded structure. And then in this way, we can define a class iterably sharp generated model. And this definition essentially says that a transitive model M is class iterably sharp generated if and only if it's the union of all the iteration of the iterable sharp that can be formed. And this has very good properties because any satisfaction obtainable in height extension of M adding ordinals is already reflected into an initial segment of M. And this means that we can reduce many reflection principles into a single property of a model. So for example, a model M being class iterably sharp generated entails reflection from M to initial segments of the nth order logic for N. And these are all very good properties, and we like them. And here you can see a useful picture of what is going on. Here we are taking the first initial structure. We are iterating this structure using ultra powers, and here we are sending the critical point k of the first structure higher and higher and higher, and we still have embeddings from one structure to the next one. And then when we took the union of all the structure, we have the class iterably sharp generated model. And here we can arrive to my principal argument. That is that ZFC plus large cardinals is restrictive compared to the V-logic multiverse. And this is my claim. Here I take the V-logic multiverse and I intend it as ZFC plus large cardinals plus the multiverse axioms that I introduced before. And I say that, and I argue that this theory maximizes over the single universe framework, and I intend the single universe framework here as ZFC plus large cardinals. And how can I try to argue and prove for such a claim? Well, first of all, I have to find in the V-logic multiverse an object that cannot be present in ZFC plus large cardinals. And then I have to prove that this object realizes a new isomorphism type. And this new isomorphism type is not available in ZFC plus large cardinals. So I'm just mirroring here Maddy's argument against V equals L. And I argue that this is possible. And why is that? Well, in the V-logic multiverse, there are proper uncountable generic extensions of V. And we can point to this generic extension of V using V-logic plus the multiverse axiom schema. However, if there are these generic extension of V, then there are iterable class sharps of V, because these class sharps for V can be there if and only if there are generic extensions. Otherwise, we cannot find them. And moreover, if there are these generic extensions of V, then V is itself class iterably sharp generated in our V-logic multiverse. And this obviously realizes a new isomorphism type between the models generated from all these class iterated sharps. However, I only prove that we have this extra object, and this realizes a new isomorphism type. I didn't talk about the fact that this is that we cannot find this in ZFC plus large cardinals, but this is the case. In fact, we cannot have any of this. We cannot have proper uncountable generic extensions. We cannot have iterably class sharps in V, and we cannot have class iterably sharp generated models in ZFC plus large cardinals. And this is the case because otherwise we would be able to prove the existence of a cardinal that is both regular and singular. But this is not possible in ZFC plus, and we cannot have a cardinal that is both regular and singular. Regular cardinal is a cardinal which cofinality is not equals to itself. A singular cardinal is the one that is equals to itself. So here I argue that in the V-logic multiverse, we actually can have an extra object that we cannot find in ZFC plus large cardinals. And we can see the same argument from another angle here and try to understand what's going on when moving between ZFC plus large cardinals and the V-logic multiverse. So, for example, when we move from ZFC plus large cardinals to the V-logic multiverse, we are not losing anything because we can still find V as the grounded universe, and this is the same V instantiated by ZFC plus large cardinals, and this is from the core axiom. And still from the core axiom, this grounded universe satisfies ZFC plus large cardinals, just like in classical set theory. And we can find all the large cardinals, all the object, and all the usual results that you would have in classical set theory. On the other hand, when moving from the V-logic multiverse to ZFC plus large cardinals, we are actually losing a lot of stuff. First of all, we are losing proper uncountable outer models of V. And this is because in classical set theory, we don't have proper uncountable outer models of V, because even when we are doing set generic forcing or class forcing, well, class forcing we cannot, it's more complex, but even talking only about set generic forcing, we're not applying set generic forcing to the whole of the set theoretic universe V, because that would imply the existence of a V generic filter. But we cannot have a V generic filters because that would imply that that there are some missing subsets in V. But V is supposed to contain all the possible sets. So when applying set generic forcing, we say that we are applying that to a countable transitive model of ZFC that sits inside V. And then we are just adding, and since it's inside V and it's not the whole V, it's perfectly fine if there are missing subset and then that there is a generic filter on it and so on and so forth. But in the V-logic multiverse, using V-logic and our axioms, we can actually have these proper uncountable outer models of V and point at them. But if we don't have these proper uncountable models in classical set theory, then we are also losing class iterated sharps. And if we don't have class iterated sharps, then we don't even have the class iterably sharp generated models. And so here we are stuck. We have, when moving from ZFC plus the V-logic multiverse to the V-logic multiverse, we are not losing anything. The other way around, we are losing a lot of stuff that we want because it has nice properties. And so how can we make all of this better? So first of all, is this argument safe from a devil's advocate? So in Maddis 1998, Maddis argues that it's possible to reverse this maximizing argument and have a, let's call it a dummy argument that proves that actually it's ZFC plus V equals L that maximizes over ZFC plus there exists zero sharp. And why is that? Well, because we can say that in ZFC plus V equals L, there is no transitive model of ZFC plus there exists zero sharp. So sorry, that ZFC plus V equals L implies that no transitive model of ZFC plus there exists zero sharp can contain any uncountable ordinal. And this is because no countable ordinal can be isomorphic to an uncountable ordinal. And we would have this isomorphism otherwise, but it's impossible. Hence, ZFC plus V equals cell can realize an isomorphism type that cannot be found in ZFC plus there exists zero sharp, and thus it maximizes over it. So Maddie, it's herself argues and recognizes that this is a dummy argument. Nobody believes that ZFC plus if V equals cell actually maximizes over ZFC plus there exists zero sharp. However, is the argument for the V-logic can the argument for the V-logic multiverse be reversed in the same way? And if yes, it's a little bit of a problem. And if not, well, it means that this is actually a good argument. And another way and another important further step is to make this argument more formal. And consider, I must admit that until now I was quite loose talking about the theory, and that is the ZFC plus large cardinals plus the multiverse axioms or only ZFC plus large cardinals, and on the other hand the model, the universe, the semantic part, so what we call the V-logic multiverse or the cumulative hierarchy V, and so on and so forth. To make this more formal, I have to talk only about the theories. And this means moving from the notion of isomorphism types to the notion of interpretation, and then of fair interpretation, and so on and so forth. And this notion of interpretation is just between the two theories. And this means proving that ZFC plus large cardinals is restrictive compared to ZFC plus large cardinals plus the multiverse axioms, without talking about the V-logic multiverse and all the universes and all the uncountable outer extensions, and so on and so forth, and without talking about V. And this is the same road that Maddie's follows when moving from her first argument, I guess ZFC plus V equals cell, then she defines this notion of interpretation and fair interpretation, and so on and so forth. So this would be the next step. And that was all. Thank you very much for your attention. I hope I was on time. And I'm looking forward for all the comments, and I will try to answer to all of them as soon as possible, and see you all next year. Bye.